Very good afternoon, all of you. So today we are going to start the fourth day of the faculty development program. So today our speaker is Dr. Saptarshi Goswami. Dr. Saptarshi Goswami is an assistant professor at the A.K. Chaudhary School of Information Technology, University of Calcutta, with extensive experience spanning academia and the IT industry. He earned his PhD in computer science from the University of Calcutta with a joint supervision from Iwate Prefecture University, Japan. Key research interests include machine learning, feature selection, data analytics, and intelligent system, with 40 plus publications in reputed journal, conferences, and book chapters. He also served as a visiting scientist at Iwate Prefecture University, Japan, and has guided several postgraduate research students. Dr. Goswami brings significant industry experience from organizations such as Cognizant, PwC, and Tata Infotech, and actively contributes to the research community as a reviewer, session chair, and workshop convener. So I request Dr. Goswami to take your session. Thank you for coming here.
So, am I audible?
Yes, sir. Your voice is
Yes, sir.
clear.
You are audible and visible too.
Perfect. Thank you for the confirmation. Thanks, Professor Datta, for the kind introduction. So what I'm going to do is, what I'm going to assume is that as it is the fourth day, you have already understood something about agents. Okay. But now, like one of the things, though, as she mentioned, I am quite involved in research activities as well as in some cases consulting. But I always feel, that to get to the core, right, you need to have some implementation experience. Okay, so something you need to do on your own. Okay, so though it is not kind of a hands-on session that I've planned, but I will try to give you idea, when you are trying to plan agentic system, okay, what kind of design patterns you're going to follow, right? What for each of the design patterns, what will be different use cases and all that. Okay, so that will be primarily my focus. I may also discuss a little bit about agent development kit, which is the toolkit by Google for agent development. So without delaying further, let me just share my PPT. Yeah.
So you are not properly visible. Can you just tilt your camera a bit?
Okay, so I can't see myself actually. Let me see. Oh,
Yeah, that's fine. That's fine.
yeah. Sorry about that.
No, it's fine.
Okay, so let me just bring it up. I hope my screen is visible.
Yes, your screen is visible.
Correct. Okay, so the title that I thought is, right into agentic AI. So the expectation is that after you attend the session, who are interested, you will go and start doing things using these agentic concepts and frameworks and so on and so forth. Okay. So there is one slide which, sorry, there is one slide which probably talks about me. This has been adequately covered, so I don't want to dwell on this. But this is just for your reference. So, if you are interested in any of the activities that I'm attached with, like, that may be Society for Data Science, or that may be, some of the things that we are doing in Calcutta University Data Science Research Lab. So that's why this gist is there, just in case it is needed. And we have also published a couple of books which are here, as you see. We also have an upcoming title schedule with Pearson itself on generative AI. But the way things are changing, I don't know, how much of that content will be relevant. Okay. So anyway, so that's a different thing. All right. So let me now just uh, let me just talk about what is an agent, right? Uh, so, agent as a concept in AI is not very new, right? So, if you take up that AI Bible book of Russell and Norway, you will see that we have been talking about agents for long, long time. Okay. And you will also probably agree with me that after you have this, transformer based large language models, okay, the leader of the pack being OpenAI, right? People started taking AI more seriously. Okay, so earlier, AI had many promises, but then uh, as far as delivery, so delivery, if I try to think that it may be, quality of life for citizens, or maybe ease of doing business for organizations, right? So broadly, if I look in this way, of course, I mean, you can think of other supporting things like, education, health, and so on and so forth. But I would try to put it under like ease of delivering service, quality of service. Okay. So if you think in that manner, there was not so much of a tangible impact over there. Okay. So when generative AI came, actually, all of us got an AI tool at its raw capability. So you don't need any application, right? You don't need to download anything. You can just go to your browser, use your credential, and you start interacting with it, right? And then there are so many stories around it, like how people's life changed, how they got addicted, or even how using this technology you could automate a lot of downstream tasks. Okay, so you will hear about that. A certain travel company who had 600 employees. Okay, after they adopted this generative AI based programs and all that, right? They could take it down to two. Right. So I have had similar stories about many organizations actually. Okay. So here I just try to give you a very basic idea. Okay. So when we are talking about AI agent, we are talking about generative AI agent. Okay. Though you will see that we are talking about workflow agents and custom agents also, but the main driver of agent was the generative AI agents. Okay. And it can actually be given a goal, okay, which we are going to discuss shortly. So it can look at the goal and it can start thinking that how I can achieve the goal. And it will just like, how we do stuff, right? So, if I have to do anything, right? So we look around that what kind of information we have, which is like our environment. Then also we look at that what are my enablers, right? Can I call them? Can I use my mobile? So which is a tool. Can I write an email again, which is a tool? Okay, or even I may have to go physically and meet him. Okay, so that is like an action. Okay, so similarly, agents also perceive the world and acts on it using his available tools. Okay, and they are supposed to be autonomous. Okay, so you do not need continuous intervention. So I'll give you an idea. Okay, the let's say you are trying to develop a habit that whatever new things are coming in the area of agent NLP and generative AI, right? So you are going to look at those emails. Okay, look at those. Sorry, look at those channels or look at those articles or whatever, right? So there will be many like that, right? So you can look at the paper code, or you can look at towards data science, or you can look at several medium articles. Okay, and so this is how actually what you can do is you can subscribe to the email ones, okay, all the emails, and you can probably take a look, right? So this is a task you routinely do. And what other thing that you can do is you can probably go to ChatGPT and ask that whatever has happened in last 1 week, right? You give me a summary. So that can be another way, right? But when I'm trying to do either of this, okay, so first problem is that, of course, these tools, ChatGPT or Gemini or whatever, they have some knowledge base at the background, right? So that may not be so that may not be updated very frequently, right? So that is one of the issues. Another issue is that it is actually blocking the human's time, right? So what I'm trying to say is that every day at the same time, you need to check your email. Okay, so you need to be connected with your device. You need to, look at the email. You go to the links. You read, what are the top papers or what are the top news, and then you get an idea, right? So that's the process we'll typically follow. Okay. But when you think in terms of agentic, okay, so ChatGPT actually gave you an age, right? So you can probably give a site and ask it that, okay, what are the different important things over there, okay? But when you are trying to, you wanted to access multiple sites, right? It it may not be that much usable. Okay, so a better thing could be, right, that you probably subscribe to different emails and then have a GenAI agent, right, read those emails, probably summarize it, go at a step forward, maybe convert it to the language you are more comfortable, right? And then actually it converts it makes a text to speech. And when you are on the go, you are traveling, you can just hook into it and you can listen to what is happening. Okay, so well, firstly, that we are talking about a lot of automations. Okay, different type of tasks, right? So getting it from different websites, then creating a summary, converting it to text to speech, right? And then probably reading out to you. And not only that, right? And that should have some kind of a refinement loop. Okay, so you will always have the option to tell it that the sources that you are going through so far are not that good, so you should now include this source also, right? So these are some of the important characteristics that you see. So autonomy, less human intervention, and then as I said that it should be proactive. Okay, it should not be completely depend on humans' decision, right? And even without explicit instruction, an agent can reason about next steps to move closer to the goal. Okay, so we are going to take a very structured look Okay, so if you look at what has been the journey of agentic AI, right? So initially what happened is you probably were using the chat GPT, and then probably you could have used some rule-based triggers. So you could use some kind of APIs, and as I was telling, right, you can use some APIs and it can use some prompts and you can get answers and so on and so forth. So this was possible, and you are getting the outputs. Okay. And then one of the things, like one of the phenomenal papers of 2024 was about RAG. And by now, I think everyone knows what RAG is, right? So RAG actually connected this knowledge capability with the updated knowledge base. Okay. So your ability to understand user's query, right, was now connected with a knowledge base. So you are relevant and you are not hallucinating. Okay. And then as we move to the next step, which is the AI agents. So AI agents, actually, as I was telling, you will see that it has multiple things coming in. So it is your previous chat, it's a database, then you can plan, you have access to memory, you have access to tools, reasoning, and so on and so forth. Okay. And of course, I mean, when you have AI agents, you had agentic RAGs, right? So you had many hybrid systems, okay? And then what people also realized is that when I'm trying to do any task, right? So we have to go through that, age-old primitive design principle of breaking the tasks, divide and conquer, essentially, right? So as I said, okay, that if I would go to important tasks, so I can have a web scraping tool or web scraping agent, then that web scraping agent can move to a summarizing agent. That summarizing agent in turn can go to a text to speech agent. Okay, so each having its own capability, right? And understand from a engineering perspective also, right, that all these models, probably I won't be able to talk about that. Agent is such an exciting thing, and so many engineering challenges are being thrown around, right? So but you can appreciate that for each kind of task, right, I don't for each kind of task, I don't need same kind of model. Okay, so if I am looking for a translation model, right, which is going to be very, very specific, I can go to a particular model like that. I don't need a generic purpose model. Okay, because essentially we'll see that generic purpose models, if you try to use, these are very costly. Okay, so uh, we are doing some projects, okay, for West Bengal government through interns, right? So we are trying to improve public service delivery through AI intervention. So for one particular project, you may know, which is called as Bangla Shohayata Kendro, which actually people who are not that digitally literate. Okay, so all the government bouquet of government services. So right now there are around 340 services which are being dispatched or which are being delivered from some physical centers, right? So citizens can walk into the centers. There are operators who can help through them and do the thing online, right? Okay, so we are trying to build some system for them, right? So in terms of recommendation, in terms of kind of a operator's companion. Okay, so it is not possible for them to be on top of all the 340 services they are delivering, right? But so when we are estimating, we are doing a very conservative estimate. Okay, so we are seeing that in terms of API calls and token usage and so on and so forth, okay, the cost per month would be easily touching around 2 to 3 lakhs. Right. So this is again, as I said, this is very, very pessimistic, very, very conservative estimation. So this is one of the challenges when you go for API based models. Okay, and if you think that okay, I will take the other way around, right? So I will take a kind of I will take a kind of model which is a small SLM, small language model, right? And then I will fine tune it. Okay, fine tune it and maybe align it or so on and so forth. It is also prohibitively costly. So I was just discussing about one of my friend in Google. So they are saying that, a simple 100 GPU hours or 100 GPU hours for the fine tuning hours, the cost will run around crores. Okay. So yes, AI is promising a lot of things, but there is a cost involved. Okay. And this is where the engineering things actually comes into play, that how you optimally use your resources, right? It's not that everything that you have been doing so far, right, need to be replaced by agents. Okay, though perception is reality. So if now the CIO is not talking about agents in their roadmap, probably they are not going to get enough budget from management, right? So you need to stay cool and tell that, okay, no, my organization is using AI in this many things, right? So of course that is there. All right, but essentially, these are the four phases that I can break down into. The first was LLM workflows, then RAG. AI agent, we are talking about mostly a kind of a single agent. Okay, agentic AI is where you are building a multi-agent system where the agents need to talk to each other. Okay, so this is the basic idea, right? And this is from one of the articles from MIT Technology Review. I forgot to mention the source. So what it notes is that agents are executing end-to-end workflows across lead generation, supply chain, customer support, and finance. Okay, so many areas it is working on. And just look at the sheer number, that even for a mid-sized organized, right, or mid-sized organization, for their different workflows, they can need like around 4,000 agents in parallel, which they can operate. Okay, and as you are deploying agents in different places, it can increasingly impact your revenue, uh, the compliances, and as well as the customer expectation. Sorry about that. Okay. Uh, and people are gradually moving towards agent-driven enterprises. Okay, as I said, economic benefits are too significant to ignore, because you need you need less people, you are doing things fast, your workflow cycle is reducing, which is decreasing your cost. And if you are if you can result that into customers delight, then of course that has the potential to affect your top line, right? So everyone is looking at agents from very close quarters, right? uh, However, so this is a slide which you will not see being talked about a lot. Okay, and this is just one of those slides. Okay, is we have always talked about this, right? Garbage in, garbage out. So agents, if they have to work, right, they need data at the background. Okay, and this is where you see, this is what the survey tells, right? That the data, many cases, is not clean and unified. Okay, it is not governed and compliant. Okay, it is not context rich, or it is not available instantly, right? So this was a survey which actually tells about that why an AI initiative have stalled or failed because of poor data quality. Okay, so it was probably you can see it was a 2024 survey, right? Not a very old one. And like 27% of those where AI projects stalled, they said definitely data quality was a reason. And these are just the other type of categorical responses. So is it definitely, is it probably, is it neutral, and so on and so forth. Okay, so you can build agents, right? That's not a problem. So we are consulting one company in a space of home decor, right? And if we think about agentic interventions, one of the things that we are seeing is that they're directly accessing, their OLTP system for data, okay, which is not a good practice, because as you are directly accessing the operational systems, right, that's a load on the system. So your traditional architectures, right, having a OLAP layer and so on and so forth, that you are not having, right? There is no governance layer, right? So the data that is coming out is not that usable. So naturally, when we are trying to come up with some decisions, right, so that is also not that correct. Okay. So this is also one of the thing, very, very important thing that needs to be kept in mind. Okay. Now, so this is only one slide of skepticism. All other slides, we are going to say, hell agents, right? Let's dive into that. So what this agentic magic or agentic frameworks promise, right? So the thing that actually, if any one of you have done this thing, so traditionally, how would we, write kind of a loop, okay, or write kind of a program, right? So we'll try to understand the business logic, and then we'll try to convert it into different details blocks, decision blocks, and iteration blocks, right? So so on and so forth, okay. But uh, that's what actually is a limitation of such a fixed control flow logics. Okay, think of something when you are trying to use AI for autonomous cars. So that's an extreme example, but Google and many other people, Uber and all, are working on this for a long time, right? So you cannot have a fixed if-else block, right? In a dynamic environment, right? Dynamic real-time, real-world environment, right? So you cannot go and start writing every possibilities. Okay, that let's say you are going through a jungle and suddenly a wild animal comes to your in front of your car, then what you should do? Probability is very less, right? But that can happen. Okay, so uh, that's where this fixed control flow kind of thing uh, in logic. So again, let me step back, right? So when we are building software, or when we have been, so let me correct myself. So when we have been building software, right? So we have been actually following this very fixed structure. You think about it, that you are building something for a software product for a bank, right? So there is a specific way a particular routine or program will execute. There's no two way about it, right? But think of this, right? So when we do stuff, okay, then uh, it is not that fixed. Let me give you a very quick example of cooking, right? So let's say you are cooking something, right? And then it's almost done, and then you are trying to test it. You say that, oh God, it has turned out to be quite salty. Okay, so what to do now, right? So you are maybe you will try to add some tomato ketchup, or maybe you can add curd, or you can add some sweetener or something, right? But was this in your original plan? It was not in your original plan, right? Or when you are going somewhere, okay, and you thought that, okay, there is a budget of, let's say, 50,000 rupees, okay, and you are asking your program to maybe make a plan to match the 50,000 budget, okay, and whatever possibility it tries to do, okay, it says that no, it actually runs above 100 rupees, right? But if you're a human being, you'll understand that 100 rupees is nothing considered to 50,000. You can manage that, but a software system will stop. Okay, so this kind of the way we operate, so it's like bridging the gap between human thinking and IT program thinking. That's what actually agentic AI enables. Okay. So as you see in the next slide, a classic rule-based automation follows a fixed path, and when it encounters an unexpected obstacle, it breaks. Okay. So agent has a reasoning model. Okay. So it has the potential to observe, adapt, and find another way. And it possesses some kind of a digital common sense, which comes from different knowledge bases, its previous experiences, feedback from the environment as well as the users. Okay. With which it can get to the next step. Yeah, just a second. So if you take kind of a anatomical view of the agents, okay, so you have your agent runtime, okay, which will have a model which is like the brain, okay, and you will have access to tools, okay. So tools may be a Google search tool may be an API by which you are, so where you are trying to get maybe name of trains, okay, name of trains running between two stations, okay. And then you have orchestration. So orchestration actually tells you it's the workflow. So what orchestration will have access to, orchestrations will have access to your memory, your reasoning, right? And, schedulers, your goals, and so on and so forth. Okay. So this is where, I will try to give an example. Okay. That here we will define that, do this task first and then do this task. Okay. So this is where you provide those instructions, okay? Or if you want to store something in memory, so this is where you handle it, okay? And this is what are the different components of an agent, okay? Where if you are trying to build an agent, you need to put consideration about all these components, okay? And this is a very generic slide where we try to differentiate between a model and agent. So when I talk about model, it can be a machine learning model, it can be a deep learning model, it can be a large language model. Okay. But essentially, for models, knowledge is limited to what is available in their training data. Okay. You have to you have to take it very generically, right? As I said, it is true for machine learning, deep learning, and LLMs. And if you look at agents, the knowledge is extended through the connection with external system via tools. Okay, so if I am talking about some current event, right? Maybe what is happening with the cases that are going on in Supreme Court right now, right? So uh, uh, the model will not have access to that, right? But agents can have access to that through use of tools, right? And it has a single inference or prediction based on the user query, unless explicitly implemented for the model. Okay, and then you cannot manage session and so on and so forth. So here, first of all, you can run inference multiple time with a memory. Okay, so it can be multi-turn. Okay, so you do some query, you get some result. With that result, again the LLM does something, or it asks for some input from you. Okay, and so on and so forth. Okay, so this is an important term, please remember, which is called as multi-term. Okay, the models will not have any access to tools and anything, right? So this is a this is a box that is available to you, right? But agents are like Lego, so you can add different capabilities to the agents in terms of tools or different agents and so on and so forth. Okay, and then you don't have any logic layer on top of it, right? So but whereas you can use something called as cognitive architectures like COT, which is chain of thoughts, or react, reason, and act, right? So these type of cognitive frameworks you can use through frameworks like LangChain and all. Okay, and I will tell you one thing, that, right, if you are planning to start your agent programming, if you have not done already, the first program, my humble request will be that write in simple, Google Colab, okay, and don't use any framework. Okay, you can jolly well do that without any framework. If you use framework, what will happen is that a lot of the things that is happening in the background you would not have any idea. Okay. All right. So we have already discussed about this, right? So important components being your model. And just a second, I'm just. Yeah. So the main components are model, tools, and orchestration. So model is you call it like the brain, okay, which give you access to ALM or LLM. So it is general purpose, okay, and it can use frameworks like COT, React, as I said, okay. And then you have tools, okay, all right. So tools are like uh, uh, the LLM needs to access some API. LLM need to do some database search, right? So all these things happen uh, through tools. So this gives the models the hands and legs required to do some action. Okay. And then you have orchestration. So as I said, the orchestration, what happens in an orchestra, right? So he will tell you, right, that how you will symphonize in an orchestra, what will go fast, then what will go, right? And then there is also, as I said, a memory in terms of state management, and so because you need to keep a track that what has happened so far. Okay. All right. So now I'm delving into that. What is the agentic AI problem solving process? Okay. So these are 5 steps. Again, this is one framework. You can think in terms of very different frameworks also. Okay. So the first step is get the mission, or you can think like defining the task, right? And then you go to what is called as scan the scene. Scan the scene means that uh, you are saying that, okay, what input is available, what resources I have got, right? And then think it through that, okay, what steps I'm going to follow, okay? And then what is the order of the tools and so on and so forth, okay? And when you have planned, then you take action, right? And then you learn and get better. And this think it through and take action can go in a loop, right? So so I have a small example, probably we can discuss when we go there, right? So you may, as I said, that it can be multi-turn, right? So you give an input to the LM, it thinks and give you the output. Again, with the output, you give something else. So it can actually be a multi-turn process, okay? And then if you look at the complexity of the agents, right? So you can divide into 4 basic layers. Okay, level 0 is the core reasoning engine. Level 1 is the connected problem solver. So connected means that it has access to tools, right? Then you have strategic problem solver. Okay, so strategic problem solver is it is not just a static workflow where the LLM is using multiple tools. Strategic means it knows that when to use what, right? And optimal use of tools, right? And then level 3 is rise of collaborative multi-agent systems, so from single agent to multi-agent. So these are the 4 stages, or 4 different categories of agent. Okay. So here I have just detailed out this little bit. So these slides will be with Professor Datta, and she can distribute it. I don't want to take a lot of time explaining this. So level 0, I'll just tell the example. Level 0 is the core reasoning engine, right? So actually, it is just using the LLMs, right? Explaining how elections work. You summarize a historical event, okay? Or help me to teach a mathematical concept, or teach me a mathematical concept, okay? So these type of things you take care in the core reasoning engine, right? So one of the issues is, it cannot check or update facts, okay? Then you come to connected problem solver. So here is where actually it becomes an agent. Level 0 is not really an agent, okay? So, you are just checking current weather and suggesting what to wear, right? So you need to check the current weather, right? That's where you need access to tool. You need the connection to external world, finding restaurants between 2 locations. So you are giving 2 locations, you need to get their maybe street address, and then you need maybe you need to calculate what is the midway around these 2 locations. And with that, you again go to call a map API and go to retrieve the available restaurants. not only are available restaurants, probably you go one step ahead and see that their price and rating and so on and so forth. Okay. Level 2 is strategic problem solver. So here you are trying to plan maybe a traveling itinerary, okay, by weighing cost versus comfort versus time, right? And revising the plan when constraints change. So uh, it's uh, it's more you can see that the amount of cognitive capability that is required is more than what you had in level 1. Okay, but typically, these tasks are also achievable by the use of single agent. Okay, and then you move to what is called as collaborative multi-agent systems, right? So this is where you break up the tasks, right? And when you break up the task, you need to think of that how this task will be done by different agents and how they will collaborate and exchange information and so on and so forth. Okay, all right. And this is a very detailed architecture, okay, that so this doesn't, earlier we are only talking about agents, right? So here we are talking about a full-fledged system, okay, full-fledged system, right? So you have your agent runtime, okay, so you have agent and agent development framework and so on and so forth. So when I say agent development framework, I am talking about maybe ADK, right? The agent development kit, or I'm talking about frameworks like LangChain or LangGraph, right? And I go and talk to the AI model, right? And then I have access to memory, and then I have access to tools, right? So this is the basic idea. However, if I want to expose finally my AI model, so as example, right? I was talking about some applications we are developing. So these applications need to be available to the users, right? So they are not going to they are not going to come and type at chat GPT. So I need a proper user interface, right? So that I can build using Gradio or this Streamlit and all, right, to start with, and then the users can get a feedback. Later I can take it to a more robust kind of a UI. But UI or a front-end framework is also essential to completely ground an AI system. Okay. All right. So now I will go to the main part, which is talking about the design patterns. Okay. That what is the meaning of design pattern? So agentic design pattern means that there are multiple tasks agents can perform. Okay. And then I can put the building blocks in different ways. Okay. So people realized or people observed that, if uh, we try to think at a very philosophical level, right? So based on the task, you have only certain set of patterns that appear while designing an agentic based system. Okay, so these are the patterns that I'm going to talk. Again, it is not exclusive list, and this is getting updated very fast, right? So see, single agent architecture we have already discussed, right? But this is how we typically annotate them. Okay, so example is a customer support agent must query a database to find an order status. Okay, or we can use a LLM, do text summarization or sentiment and analysis. So this doesn't need agentic system. Okay, the first one needs an agent. Okay, so one of the important patterns is called as prompt chaining. Okay, so what is happening over here is that if you see that there are multiple agents that you see, okay, that you are giving a prompt to the agent, right? And this agent's output is again going to another agent, okay? And that output is also going. At the same time, the user may also have the option to give some feedback, okay? And that way, you have multiple prompts and you have multiple agents working together, okay? So this type of design pattern is called as prompt chaining. And here is a very brief example. Let's say, what we try to do is generate 5 topic ideas based on users' general interest, okay? So, and then you probably give instruction that processing allow the user to select, or this is what the agent is doing, allow the user to select one idea or automatically choose the best one. Okay, now prompt 2 is based on the selected topic, generate a detailed outline. Okay, uh, Then prompt 3 is write a draft section based on the first point in the outline. Prompt 4 is write a draft section based on the second point in the outline. Previous and so on and so forth. And this is something, we also can do like without even agentic frameworks, which we typically call as compound LLMs. Okay, so what I can do is I can ask an agent, right, that you write an article. Okay, that article I send to the next set of LLMs. Okay, so what is the input? The input is article, and I also tell that review this article. Okay, and then I take it to the next agent. So the next agent, I pass the article, the review comments, and I ask it, that you modify the article, and then the final output goes to the user. Okay, so this is what is prompt chaining. And I would also like to take a moment and tell you that we hear the term about context engineering and prompt engineering. Okay, so prompt engineering, right, that uh, how to craft your queries, which you are sending to the AI model. That's prompt engineering, right? But context engineering is a more encompassing term. Okay. Uh, as example, you can have RAG, you can have the memory, which is in terms of state or history or memory itself. And then you may also have you may also mention some kind of structured outputs. So this is what gives you context engineering. So you can write the prompt, but then you are adding context. You are giving a book. So that's your context. Okay. And you say that, okay, you answer from there, right? So that's your context, which can come through RAG or through other history or memory and so on and so forth. Okay. The next important pattern. Okay. And now you may ask me that why you are showing this prompt chaining under single agent system. The reason is that, we can use the same agent again and again. We can run it into a loop and use the same agent. We can communicate with the same agent, right? So that's why I put prompt chaining under this, right? This next is, tool calling. So this is another very basic type of agentic pattern. So essentially, the user gives some prompts to the model, and the agent can decide that, okay, which tool to be used. So do I need to access my memory? Do I need to access database, right? Or do I need to access any web browser? Do I need to carry out web search? Now there is a concept coming as agents as tools. I don't know, we'll be able to discuss this today, or do I need to use Google Maps, right? So here is where, based on the query, it can decide on calling a tool. At the same time, you can have multiple tools that are to be called, right? So that's why it's mentioned as multi-step tool calling. Okay. So here is an example. Okay. So tool definitions will be available, defined and described to the LLM. And this description includes the function purpose. So you need to tell that, okay, if I want to book something, then you use the flights API. If I want to do some location search, then you use Google Maps. So this is something you need to do. Okay, and then LLM can take a decision. Finally, LLM also needs to generate a function call, because this is an API, and the uh, LLM cannot give a natural language output, right? It has to generate a very structured output, which is in form of a JSON mostly, okay, which will tell that, okay, which tool to call, which argument, and so on and so on, because it is without human intervention. You are not going to pick it from there and then paste it somewhere, okay? Then the tool execution. After the tool execution is done, so please understand that even when you are doing a tool execution, maybe some problem is there. Maybe your payment integration is not working, right? So you need to observe the results, right? Mm, And then, LLM processing. So you can probably look at the observation that has come. So you can stop there, or you can run into a multi-step process. Okay, so this is possible, right? Okay, so one of the very famous agentic patterns is called as React. Okay, so for some reason, this PowerPoint doesn't allow to use this kind of camel case, but this is what you use, okay? That react, reason and act. It is one of the most prominent single agent architectures, okay, which gives you the reasoning. So, whatever, prompt chaining or tool calling, it is very fixed. React is what now gives you the flexibility. Okay, so it has steps like think. The LLM analyzes the current state and decides what needs to done, and then you take an action. It selects and invokes one of the available tools or actions. It observes, right? It processes the result returned by tool. Okay, and then what happens is that we can go into a loop of this think, act, and observe. Okay, so it is a more detailed workflow, how it works, right? So it starts from the prompt, it goes to the agent system, okay, which sends the query to the AI model. Okay, so it thinks, right? And then it can call API to gather information. So it can use tools. So this is the act, okay? And then it goes to external memory. It saves relevant observation to memory. So the AI model can now observe, okay? And then you may go into this think, act, observe, or you can update the model's knowledge to define approach. And then you send output back to agent system, and then finally send response if end condition is met. Okay, otherwise the agent may again decide to send query to AI model. Okay. I don't think like this will be visible to you, but I just wanted to give you an idea. So you can simply implement this agentic system using a prompt. Okay. So see, you just need to write in natural language. You run in a loop of through thought, action, pause, and observation. Okay. At the end of the loop, you output an answer. So you are just describing. So this is the instruction to your model. Okay. Use thought to describe your thoughts about the question you have been asked. Use action to run one of the actions available to you. Then return pause. Observations will be result of running these actions. And then we are saying that this is the actions available and so on and so forth. Okay. So in plain and simple language, you can go to Collab, you can have a model, you can have the API key and start doing agentic stuff. You don't need a framework. Okay. But that has advantage and disadvantages, right? And what we did was, it's a very simple scenario. Probably I took this from the Langchain tutorial with deep learning. Okay, so there were three actions available. There was a simple mathematical calculation. There was something called as find weight of dogs, and then there were Wikipedia search. Okay. And it was said that when the user asks a query, the agent thinks results which action to be chosen. So if someone wants to add 2 plus 3, it will use the calculate action, the A, which is simple mathematical calculation. If someone wants to know the capital of France, it will use the Wikipedia search. Okay, and if you uh, find out weight of some dog, okay, then you will use the finding weight of dogs. Okay, so here was a very interesting study. I'll just tell you. Okay, that let's say you try to find out that what is the average weight of so you are giving a statement like this. Okay, that Jim has uh, two pets. Okay, one is a Labrador and another is a husky. Okay, so what is their average weight? So the LLM will understand, right? Or the agent will understand that it needs to call this weight of dogs 2 times. One for husky and one for Labrador. And then probably when it has this weights available, then it will go and use the calculate tool to get an average. Okay. And it can be more interesting. So you can say that, I don't have only a husky or a Labrador. I also have a cat. Okay. Uh, and you specify the type of cat. Okay. So what can happen is that now it can go and do a Wikipedia search about weight of that particular type of cat. Right. So that's where it can actually, this is a very toy example, but that can, that's where the agents can amaze you. right? Okay. So going to the multi-agent system, again, as I said, that I have tried to put as much as material as possible, so you can refer to this later, right? So I'm not going through each one of this. The basic idea, yes, is that you want to break the things, right? So you want to break the things into subtasks, right? So you're rather than using a single agent with a monolithic prompt, okay, you can improve on scalability, reliability, and maintainability. So that's the objective. Okay, why we built modular system in an IT system, right? Okay, and yes, this becomes more challenging because you need to keep conversational history. You need to think how you will, pass memory between different things, and then when you build multi-agent systems, you need to additionally think about evaluation, security, reliability, and so on and so forth, as well as cost consideration. Okay. So one important pattern is called as routing. So you have an agent called as a router. Okay. As example, here you see that if the prompt is analyze the user, like if the user is giving some query, okay, the agent is actually going to analyze the query and route the query based on the intent. If the intent is check order status, route to a sub agent or a tool or a tool chain that interacts with the order database. If the intent is product information, route to a sub agent or chain that searches the product data. And if the intent is technical support, then route to a different chain. So you have multiple agents who are specialized in different things, right? And you are using a router to choose them. Okay. And this routing can be different ways. So it can be a rule-based routing. You can do a ML model-based routing. So whatever historically has happened that has generated training data, you can train a model on that. So when the query comes, you tell that, okay, which agent to be taken, right? It can be embedding-based routing. So the agent's description is there. The query description is there in terms of vectors, embeddings, right? So you can see which one is similar and you can put there. And of course, finally, you have the LLM-based routing. Okay. All right. This is also very, very important. Okay. So I don't know how I'm doing on time. Let me go to Professor Datta once. I think we have 2 more minutes, right? Professor Datta, are you there or anyone from SNU?
Yes. 2 more minutes.
আমি আপনাদের একটা অবজেক্টিভ আপনি কি করে হেল্প করতে পারেন না অবজেক্টিভ আমি আপনার নাম্বার দিলাম ফোন করলাম একবার
আচ্ছা এটা আপনার ফোন ছিল
হ্যাঁ
না না আমাদের
So
এটা আপনার হোয়াটসঅ্যাপ আছে
if anyone has any question, you may please ask.
No, actually, it was not that purpose. So what I wanted to say is that, like, can I go on for maybe another 5 minutes?
Yeah, that's fine. No problem.
Yeah. So what I'll do is so it is 3:59. I will go up to maybe 5 minutes past 4, and then I will take 2-3 minutes if there is
That's fine, sir. Yeah,
So
sure,
one of
sir.
the very important pattern is called as
লিঙ্কগুলো পাঠিয়ে দিও
because typically what happens,
মাইক্রোবায়োলজি
that when we do something, we can reflect. But ChatGPT-based systems, which actually generates the next token based on different tokens, it has no concept of backtracking. The reflection actually gives that capability, okay, that you can self-critique yourself. The first pattern is self-reflection, and the second pattern is that you can have other
around 11
agent to critique.
আচ্ছা তাহলে
11 till 12:40 আমার ক্লাস আছে 12:40 পরে আর কিছু নেই
আমার আবার 1:30 থেকে ক্লাস আছে ঠিক আছে আমি আসুন বসে
Okay, so let me go to the next pattern. Okay, I think some people are not in mute.
3:15 3:20 নাগাদ বসে যাবো তাড়াতাড়ি
নো প্রবলেম আমি চলে আপনার
Can they be muted? All right. So this is amply used. React.
Sir, you are on mute while talking.
Yeah. So basically, you can use it when you are developing code. So you first agent actually develops a code, the second agent reviews it, right? So that is possible. And then one important thing is also human in loop, right? So we are experimenting with agents, okay? And there can be very critical decisions that need to be taken, that maybe, you are directly responding to thousands of citizens through a bulk email, right? So at that point of time, you actually may send it to a human reviewer, right? So you understand that certain tasks need to go to human reviewer. Okay, and then if that is not approved, right, you can you can go in a loop and refine. Okay, very important one. So use case, maybe an agent might be tasked with anonymizing a patient data set for research, right? But then if it has to share with someone, before that you want some human to take a look at that, right? Another very important point is called as guardrails. So guardrail, why it is important is that when you are doing something agentic, you also need to ensure that you are putting proper best practices. Okay, so this is what we call as guardrail. So it should not be that I'm sending a toxic comment back to the user, or even the prompts. I should not entertain things which are harmful, right? So both ways, okay? So when you put some kind of checks like this in terms of, defensive prompting standards or input validation and sanitation standards, then, this is also one of the uh, important, important agentic patterns. Okay, so it can be used in customer service chatbot or content generation system. Okay. Now, quickly, I will talk about ADK. Okay, so ADK, again, I'm not promoting ADK. You can use LangChain. You can use Open APIs, Agent Development Kit. You can use Anthropic's Open Development Kit. Anything you can, Agent Development Kit. You can use any one of them. Okay, so uh, uh, the ADK actually allows us this. Google ADK allows you to use Gemini or any other model, right? And then it is deployment agnostic, so it's not that you need to use tools only available in Google framework, right? And then it is interoperable. Okay. So you can take that to another system, or you have implemented something in LangChain, you can bring it here, and so on and so forth. Okay. And I just wanted to quickly give you an idea about how all these things happens. And yes, one way, as I said, is through, of course, your you're writing in a Python code. That is possible. But then using this framework, it gets very easy. So if you see that this is kind of a master agent, where you are seeing that, okay, what is the name of the agent? You are saying which model to use. You are giving a description, and then the detailed thing that it has to do, you have put in a file which you are taking from here. And then you can also define sub-agents like, like an array. Okay, so these are the agents that you are going to use. Okay. And then I have delved into the next sub-agent. So here also you have similar pattern. One additional thing you'll see is called as output key. So output key, or you'll see tools, right? Now also tools, you see that, it has been given as a collection, right? Uh, so this is that easy. So when you use agentic frameworks, what happens is your development becomes easier. So I'm not saying that you should not use agentic like agent development kits. When you are developing something production grade, you need to use it. There's no doubt about it. But when you develop from scratch using your Pythonic knowledge, okay, so you get a better understanding. That's all. And if you look at ADK agent types, right? So it is classified as firstly LLM agents, right? So which are LLM based agents, and then you have the workflow agents, which are covering your orchestration. So sequential agent, parallel agent, loop agent, and you may have a custom logic agent also. So you can put your own type of code. Okay, over there, maybe a time series model, maybe a computer vision model, or maybe something else completely, right? Maybe your universities or your organizations, payment policy or something like that. Okay. And so sequential agents will look like this. Okay. Parallel agents will look like this, right? And the loop agent will actually have things happening in iteration. Okay. So this is what I actually intended to cover. Okay. And these are the references. So the agentic pattern. So this is a person you can follow called as Antonio Gulli. So who is developing a lot of things on agents, right? So the book is freely available. If you don't have an access, you can get in touch with me in LinkedIn or something, and I can help you out. Okay. You can look at the GitHub code. The GitHub page of ADK Docs, and then Kaggle also has. So actually, Google has a very elaborate program called as 5 days of AI program or something. So you can look at the 5-day agents, and you will get beautiful white papers for each of the day. Okay, along with the podcast which are generated through Notebook LM. Okay, which is again agentic, right? And these are very good resources. There are many. I just mentioned 2 or 3 of them, so I didn't want to give a choice of much, right? Okay, so that's brings me to the closer of these sessions, and thank you so much. So if you have any questions, then I am available to take your question for some time. Is there any question from anyone? So as I said, I mean, I will give my email ID just in case someone wants to get in touch. Okay. So I think then that's all from my side. Thank you so much. And
Thank you, sir, for this kind of valuable session. Hope everyone enjoyed the session.
thank you.